Okay, our next presenter is Jeremy Siadal. Jeremy's a senior HPC software engineer and the Intel technical lead for OpenHPC. And OpenHPC is exactly what he's going to be talking about. He's going to give an overview as well as give us an idea of the future direction of this open source software project. Jeremy, welcome.
Thank you. Can everybody hear me okay?
Yes, can hear you just fine.
Great. Let me go ahead and start a presentation here. My name is Jeremy Siadal. I'm a senior software engineer and a 21-year veteran of Intel Corporation. I'm here today to talk about OpenHPC. And what I'd like to do is provide a little bit of background on OpenHPC and then go into more details about what the project entails. So let's start with a quick introduction. OpenHPC. OpenHPC is a collaborative open source software project that was started in 2016. And the goal was to bring together members of the HPC community in order to create a common repository of software. Basically, they looked at what was available in the HPC software space and thought that by working with the different software creators, they could pull all these different ingredients that go into an HPC cluster and pull them together into a central location so they could provide components that were pre-built, tested, and integrated and make those available. Now, ultimately, OpenHPC is a software repository. And we also like to say OpenHPC is a software distribution. So it provides a collection of ingredients that are common for most HPC clusters. And those different components are all pre-built and readily available as RPMs for use with any of the Linux distributions that use RPM. So we have these tested on CentOS and OpenSUSE currently. We also have a previous version still available that's tested and supported on CentOS 7 and SLES 12. And that's important because what OpenHPC is providing are building blocks that are not only tested themselves, but they're also integration tested with one another. So if you're using the OpenHPC solution, you can be assured that the different components available will work together. Now, we provide a wide variety of components, but users don't have to install all of them. So we have everything from the provisioning system to help build a cluster all the way through the performance libraries, performance tools, compilers, and other components used in a cluster. But you don't have to use all of it. It's quite common, for instance, if you just want Slurm, for example, you can install the OpenHPC repository and just install those components necessary to set up Slurm on your cluster. One of the other things, in addition to providing these components, is that we also provide a community around it. And that includes things like recipes for installing clusters. We've got a user mailing list that we can provide support. We've got tutorials, and we have other things that we provide to make these, make building and implementing clusters easier. So as I mentioned, this is a community project, and this is the current list of our corporate and non-commercial members. And again, all of this is managed through the Linux Foundation, or under the umbrella of the Linux Foundation. If you're interested in a member, contact information is on this page. So OpenHPC has seen a fairly wide or fairly broad growth since its inception in 2016. And we're looking at, now I can't provide specific information on the total number of actual implementations or clusters built with OpenHPC, but we do collect statistics on how often and how much our repositories and site is accessed. And you can see it's been a consistent growth of the project over time. Version 2.0 was released, excuse me, 2.0 was released late last year, and one of the noticeable trends is a major uptick in the number of people accessing the 2.0 software. I think a lot of this being the fact that 2.0 made these packages available for CentOS 8 and OpenSUSE 15. Okay, so that's the program. So let's talk about some of the highlights, and specifically the ways that the program can benefit its users. OpenHPC provides a fairly comprehensive set of standard HPC software. And if you look through this list, you'll see, I would say most of or I'd say a lot of the major components used in, for instance, administration, provisioning especially. We provide Werewolf pre-built. We support XCAT. We don't provide the pre-built binaries, but we provide recipes for building OpenHPC clusters using XCAT, as well as Slurm, OpenPBS, and other components. Now, one of the things, and actually one of the things some of the folks on this meeting especially might be noticing, is that AI support, and it's one of those things that we're certainly looking at. And there is the question of providing AI support through RPM packaging, and since most of the AI support is currently today provided through different distribution methods. One of the key benefits of OpenHPC is its direct support for software development tool chains. So when OpenHPC is installed, one of the components is LMOD, and that's the environment module management. And it is configured to readily support the apologies for that. There we go. It is configured to readily support multiple concurrently installed software tool chains. So you can have several tool chains. And when we talk about tool chain, we're going compilers, MPI libraries, performance libraries, as well as libraries specific to individual applications. And the support of these in the hierarchical software environment means that if I load, for example, GCC, at that point, the next layer of the tool chain becomes available. So I can now use, for instance, OpenMPI or Intel MPI that's been built specifically for the GCC underlying library. Or I can switch from GCC, for example, to the Intel library and do the same thing. And so there's an entire tool chain here that allows the end user to switch to whatever tool chain is necessary to either run the application or build new applications. So as I was saying, with the launch of 2.x, we made a couple major changes within OpenHPC. One is today that it supports the latest versions of CentOS and OpenSUSE Leap. With the soon-to-be-released OpenHPC 2.1, it will formally support CentOS 8.3 and OpenSUSE 15.2. We also not directly support, but we'll also use it on the commercial equivalents of Red Hat, Enterprise Linux, and FLES. We also provide pre-built containers for CentOS 8, and that includes a large number of the OpenHPC performance libraries and components pre-installed into a container for easy use. And with 2.0, we also upgraded the MPI, GCC, Slurm to the latest components, as well as added support, direct support for libfabric and UCX into the components. So along with the latest software, there is an ongoing effort to expand OpenHPC deployment into the cloud, into a cloud environment. We have a dedicated working group, the Cloud WG, and their goal is to look at how we can best deploy OpenHPC into a cloud. If you go up to the OpenHPC GitHub, you can find the latest work that they've done, including a full working cluster solution and tutorial to install OpenHPC on Amazon Web Services. And there's also, and they're also looking, of course, using, adding the capability to create virtual machine images that would be cloud agnostic, that would include all the OpenHPC components. And it goes back to remembering that with OpenHPC, you can pick and choose the components that you want to install. And in most of the cloud environments, the provisioning systems, as well as some of the management utilities, either don't work or don't make sense. However, by attaching or adding the OpenHPC repository to a cloud instantiation of a cluster, you make an entire repository of HPC software available for easy installation. Okay, so that is a summary of OpenHPC. I do want to also just give a heads up that we will have several events coming up this year. We'll be at ISC. We'll also be at PERC and supercomputing this year. We have Birds of the Feather scheduled for all three events. As well, if you're attending supercomputing this year, we'll have an exhibit, and we've asked for a tutorial. We'll find out if we'll be doing another one of those. So let me open up the floor to questions.
Thanks, Jeremy. So the one question I have in right now is, does OpenHPC support Ubuntu? You didn't mention Ubuntu when you listed CentOS and OpenSUSE.
Yeah, and thank you. And that's actually a great question, whether we support Ubuntu. And I deliberately didn't mention Ubuntu. And the answer is we don't. And not at this time. We've had discussions about Ubuntu support. The major thing, of course, is adding the build capability to include all of the apt packaging, because that would require going through all of the individual packages and adding the apt build instructions. And so it's all doable. It just hasn't been, again, we had discussions about this. We do believe that it's important, and it's certainly something we're looking at in the future, especially when we talk about, I know in the AI and the big data space, Ubuntu is a lot more important.
And the next one kind of follows up on that. You mentioned CentOS 8. So how are you going to react on the discontinuation of CentOS by Red Hat?
So the technical steering committee has had some discussion about how we want to handle the CentOS issue. Discussions from moving to stream to looking at possible replacements. The formal answer, Carl Schultz, who is the chair of the technical steering committee, put out a press release. And right now we are going to wait and see. We have support for CentOS 8 through the end of the year. There's a lot of work going around possible replacements, and we will make the decision. All I can say is we'll make that decision soon, but we are looking at it. We will have a plan put together to migrate or provide support for that well in advance of any issues cropping up.
Okay. Does OpenHPC play well yet with Intel One API?
Actually, that's a great question, especially coming from Intel. I'm actually working right now on the One API integration, and there shouldn't be any reason why you cannot. Let me phrase. If you go to the recipe third-party recipe locations on the OpenHPC wiki, you can find a link to the Intel recipe, and I include installation instructions and integration instructions for One API.
And continuing down the support thread, another one here about OpenPBS will not be supported by OpenHPC 2.x.
It is. It's an error in the slide. If you noticed it, it said PBS professional. It is OpenPBS. It is currently supported by OpenHPC 2.
Okay. And is OpenHPC included in the OpenSUSE Leap 15.2 distribution, or do they need to download it themselves?
You'll need to install an RPM separately. If you go to the first page of the wiki documentation, I believe it's the first page of the wiki documentation, there's instructions and a link to the RPM. Once you install the RPM, it'll take care of setting up the repository.
Okay. Any trade-off between, let's see if I can read this right, Werewolf or XCAT for provisioning? Are there any other options?
Currently only support for Werewolf and XCAT directly with OpenHPC. However, OpenHPC can be installed on top of any provisioning system. And I don't make any particular recommendation. It's whatever works for you.
Okay, great. Thank you, Jeremy. Appreciate it.
Great, thank you.